While going to the week 5 discussion, the first question is regarding the traveling salesman problem. So they had given 5 cities A, B, C, D, E, and the distances from A to B, and all the distances are given. And the first question is to complete the BNB search tree is shown below. The complete. So what is the estimated cost of S naught as per the algorithm discussed in the lecture? So first we need to calculate the S naught. So whenever we are taking the S naught, the estimated cost for S naught is, so what we have to do is, this is the given thing to us. What we have to do is consider the each and every row, consider the two minimum values. So 30, 38. So what we have to do, 30 plus 38 plus the next 38 and 52. 38 plus 52 plus, and next minimum is 42, 48. 42 plus 48 plus 30, 42. 30 plus 42 plus next 60, 56. 60 plus 56 divided by 2. Okay, so this is the estimated cost you are calculating. So you will get 218. So the answer for the estimated, so the answer for the estimated cost is 218. Take that minimum among each row, add those two, and divided by the total with 2. Next, identify the first segment S1 that will be used to refine S0. What is the estimated cost of not S1? So whenever you are calculating S1, take the minimum path. So among the given paths, AD, that is 30, is the minimum. So S1 comes as AD and not S1 comes as not AD. So we are asking us to calculate not S1. Okay, so first S0, we are getting S1 and not S1. So this you got 218 and this is AD and this is not AD. Okay, so if you see in the first one, AD is 30. So 30 has to be included. So if we include 30, we calculated it as 218. So 218. So not AD means if we are not calculating the AD, if we are not including the AD as the path in your tour, means you should not consider this 30 whenever you are calculating this one. So instead of 30, you have to see the next two minimums. Next two minimums is 38 plus 48. So whenever you are calculating for not S1, that is not AD, so don't consider 30. So if you don't consider 30, what will get? 38 plus 48 plus the remaining, that is 38 plus 52 plus next to 42 plus 48 plus, so next in this row we won't consider 30. So the remaining 2 is 42, 62. 42 plus 62 plus 60 plus 56 divided by 2. Okay, so what we will get there is 243. You will get this as 243. Okay, so for this one you will get it as 243. So they ask us to calculate the not S1. So it is 243. So don't consider the AD, that is 30, whenever calculating. Take the next two. If it is 30 is there in that particular row, remove the 30. Don't consider 30. Take the next two minimum values. So here 38, 48 like that. Okay, so 243 is the minimum. Next, identify the second segment S2 that will be used to refine S1. What is the estimated cost of S2 node? So the next, whenever we are considering S2, so the next minimum is AB, 38. So S2 is AB and not S2 is not AB. So they are asking us to calculate what is the estimated cost of S2. Okay, so estimated. So here we are having S2, S2 and not S2. Okay, so this is the next is AB. So AB not AB. So they are asking us to calculate the S2 estimated cost. S2 means this one. So we are having AD is included and AB is, so AB is also included. AD and AB both has to be included. AD and AB both are included. 30, 38. So if you see here we added all 30, included 30, 38. So whatever we are getting 218, that we will get here also. Okay. So S2 is 218. Okay. 218. Next, what is the cost of the optimal tour? Okay, whenever the term comes into the optimal tour, you have to construct the entire thing. Okay, so here we are doing next AB, we are using the next S2. After the S2 we'll see what is the next. Next is the minimum is 42. Okay, so that is CD. Okay, so next S3, not S3, here also S3 and not S3. So this is AD, not AD, AD, sorry, CD, CD, not CD, CD, not CD. Okay. So if you see here, what are the things we are having? We are including the AD path, we are including the AB path, and we are including the CD path. There is a path from C to D. So if you draw this one, if you draw for this one, what will get? Say for this one, A to D, there is a connection. A to D. Next, A to B is there. A to B is there. Connection. Next, C to D is there. C to D is there. So the next remaining one is A, among A, B, C, D, E. The remaining one is E only. So there won't be any chance other than this one. So we are having this as a part. A, D, B, C, E. Okay. So this is one part. If you calculate AD is 30, AB is 38, and BE is 56, CE is 94, and CD is 42. Okay, this is one part. So if you add the total, you will get this as 260. Okay, this is one part. Now we see for this one. For this one, we are having AD, A to D. Next we are having AB, AB. Next we are having not CD. So there won't be connection from C to D. So what is the other path for connecting D? So if I connect to B, then is a closed path. So it is not true according to the traveling salesman problem. It is not having connection to C. The only one remaining is B. So there is a connection from D to E, and this is the remaining node C. Okay. So add all the insert all the values and see you will get this as 304. Add the distance from A to D, that is 30. This is A to B is 38, and BC, like BC is 52, and CE is 94, and DE 90. Okay, so if you add all these things, you will get 304. Okay, next, similarly for here, for this one, what we are having, there is a connection from A to D. There is a connection from A to D, and we are not having connection AB. Okay, CD is there again connection. So C to D is there. We are not having connection AB. So if I draw the line from A to C, it makes a closed path. So it is next node is B. It's not having connection. So the next remaining node is E, and automatically the city will come here B. Okay. So similarly, include all the values, whatever the values here. If you add all those values, you will get this is the 240. Okay. Next, while coming to here, we can't construct a path like this. You see here, AD, if I draw AD, okay, so A to D, and next we are not having connection from A to B, and we are not having connection from C to D. So then, where can I draw the connections? Here we are not having any other information. If I am not having connection from D to C, there may be any connection. So the remaining two nodes connected to D may be either B or E, but we are not having any information there. So then we will go for the another one to see the next one. So the next one is the next minimum is AC. So next consider that is S4 and not S4, that is the next minimum is AC, meaning that there is a connection from A to C, there is a not connection from not AC. Now if you see the path for this one, okay, if you see path for this one, what will get, um, we are having a connection from A to C, so A to D and not AB, not AC, then we are having A to C. Okay, that's all. And then what I have to do, CEB, BE, two nodes are there. Whether C is connected to B or E, again I am having a confusion here. So then go for again inserting one more, the next. So what we are having the next after AC, we are having BC. So whether including BC or not BC. Here also including BC. Okay, we will see whether the path is there or not afterwards. So BC and not BC. So if you draw for this one, we are having a connection A to D starting here. A to D and not AB, not CD and AC. AC is connection. Then we are having AC is there. Next we are having BC. B, C, and they told that the next remaining node is E. So there won't be any option. This is the next. Okay. So ADCEB. So if you add all these things, you will get 276. Next for this one, AD comes from the starting AD, and next not AB, not CD, AC, not BC. So see the remaining two nodes now are B and E. They told that not BC. So the remaining option is E, here B. Okay. So if I calculate for this one, I will get this as 290. Okay. Now here we will see whether we will get the path without adding BC and not BC. So what we are having, A to D. Okay. Next not AB, not CD, not AC. So if you see AD is there, not AB, not AC. So we are having B, C, D, E other than A. So there won't be connection to B, there won't be connection to C, and we had connection to D. The next we are having a connection to E only, the remaining. So AE. Next what we are having? We are not having connection to CD, not CD. Not CD means then automatically there is a connection to B. So the next node is C. So if I calculate for this one, you will get this as 288. Okay. So if you see how many paths we got, 1, 2, 3, 4, 5, 6 paths. Among the 6, which is having the least one, this one, 240 is the least one. So the least path is A, D, C, B, E. If you come this direction, otherwise this direction, A, E, B, C, D. The path is the 240. Okay. So 6 paths we got. Okay, so 240 is the optimal path tour and the ADCBE is the tour, and how many tours are represented by S1 node? S1 node is this node. So we calculated from S1 total. So we are not going for not S1. Till now we were in the S1 only. So what we have 6. Okay, 6. How many tours are represented by S2 node? S2 node means this node. How many paths from S2? 1, 2. 2 paths are there. 2 paths. How many tools are represented by not S3? Not S3 is this one. This one. How many paths? 1, 2, 3. 3 are there. So 3. Okay. So if you travel, say traveling salesman, branch and bound search tree from its root node to any leaf node, then automatically cost monotonically increases as the depth increases. Okay. While coming to the group 2, so this is the graph they had given to us, and these are the distances from the starting node to a particular node. And for calculating the heuristic value, we have to calculate the Manhattan distance. To calculate the Manhattan distance, if we are having any confusion how to calculate the Manhattan distance, see the week 3 discussion. There we explained how to calculate the Manhattan distance. Okay, first they are asked us to calculate A star algorithm to find from S to Z. Okay, so this is the graph they are asking us to calculate. So first what we have to do is we have to calculate the h of n values, heuristic values. So these values, whatever they mention here, these are the g of n values. So for A star algorithm, a function f of n is equal to h of n plus g of n. Okay, h of n is the heuristic value, meaning that the distance from the node n to the goal node. So g of n is the distance from the start node to particular node n. Okay. So here I am writing the node n and h of n values. Okay. So for yes, we are having the Manhattan distances. S is having 12, A is having 7, B is having 8, C is having 5, and D is having 5, E is having 7, F is having 4, and obviously G is having 0. Okay, now for calculating the A star algorithm, so first consider this is the open list and this is the closed list. First yes, okay, then it will move to the closed list. So the nodes connected to S will be come and occupy in the open list. So S is connected to B and E. Okay, so B is having h of n plus g of n value as h of n for B is 8 plus g of n from the starting node, so S to B, this is 6. So 8 plus 6, 14. For E, the h of n value is 7 plus g of n value is from S to E. In the graph, that is 6. So that is equal to 13. So next it will see which is having the least f of n value in the open list. So the least f of n value is having E. So E will be moved to the closed. And the parent of E is, yes, I am writing this is here is this is the parent. Okay. So already B is there with value 14, and then E is moved to the closed list. The nodes connected to E again occupy in the open. So the nodes connected to E are B, again I am writing B. Okay, this is the previous B, F, and D. Now you see what is the value for the h of n already it is 8 plus, now you see for the g of n. G of n you see first it is moving from S to E and E to B. So this is 6, this is 6. 6 plus 6, 12. Okay, so now we got it as 20. Sorry, 6 plus 6, 12. 12 previously it is 8. Okay, 20. So when you see the previous value is 14, now the value is 20. So if you calculate the next time, if you get the less value, so remove the previous value and keep the new value. If it is higher, then remove this new one. Okay, next the F value is, so F is having 4 as h of n plus the value for g of n is from S to F, S to E and E to F, because we are getting F from E. So 6 plus 4, 10. So what you got? 14. Next for D, h of n is 5 plus 6 plus 6, 12. That is 17. Now, which is the minimum among these? So F, D and B we are having now. B with 14, F with 14 and D with 17. So 14, 14 both are having the same value. Then you need to consider according to the alphabetical order. So B is first. So moving to the B. B parent is yes. Okay. Next. So what are the nodes? Already F is there with 14 and D is there with 17. Now, if we see the node B, the nodes are connected to B is A, D and E. Okay. E, if you see E, what will get here? S to B and 6 plus 6, 12, 12 plus E here 7, 12 plus 7, 19. So we are not considering this E because already E is moved to the closed list with the less value. So if you are having the value with less, then we will come back that E to the again to the open list. Now this is value is higher, so I move. So for A, the value is G of n is 6 plus 4, 10, 10 plus this 7. So 17 for D. Now already D is there with 17 value. Now we'll see how much D will get here. So S to B and B to H. So 6 plus 4, 10. 10 plus D is having 5. So 15. Now this 15 is having the lower value. So you neglect this one, you consider this D now. Okay, so previous this value we are neglecting. Now we are having in the open list with F 14 and A with 17 and D with 15. So the next minimum is F. So move that F. So what is the parent of F here? E is the parent. Now what are the nodes in the open list? A with 17 and D with 15. Okay, next. So whenever we are expanding the node F, what are the nodes connected to F? G and D. So D already it's there, and if you calculate now D, what you will get here? So from S to E 6, 6 plus 4 plus 6. So 14, 14 plus 4, 18. But here already it is already moved with the less value. Okay, D, okay, we are saying D. So 6 plus 6, 12 plus 4, 16, 16 plus 5, 21. But here D value is 15. Okay, we will leave it. So next one is G. G. So what is the G value? Here 6, 4, 10 plus 6, 16 plus 0. So 16. Okay. So the next which is having the minimum, D is having the minimum. Next move to D. So what is the parent of D? B is the parent of D. Okay. So next what are the nodes connected to D? C and B. C and B and F and E are there, but we will get the highest value. So I am not including once again. So we are having C and B. B also will get the higher value. So remove that one. And the next one the C is having. Okay, C will get it as 10 plus 16, 60, 10 plus 6, 16 plus 5. We'll get it as 21. And that's all. Okay, the next we are having G and A. Okay, G is with the 16, A with the 7. So A with the 7. So the next is minimum is G. So move G to the closed list. G parent is F. Okay, so if you see the path, we will write in the reverse way first. G to F, F to E and E to S. So the path is S to E, E to F, F to Z. Okay, so this is the path by using the A star algorithm. Okay, S, E, F, G. So what is the cost means? S, E, F, G. 6 plus 4, 10, 10 plus 4, 10 plus 6, 16. So 16 is the answer. Next, run branch BNB branch and bound to find path from S to Z. So we have to calculate the path for the same graph by using the branch and bound. So according to the branch and bound algorithm, the BNB extends the cheapest partial path. So again we'll start from the years. Okay, so if you start from the years, starting from years, what are the nodes connected to years? B and E. Okay, so what are the distances we're having? 6 and 6, both are 6. So whenever we're up to here, this is a partial solution we found. So among this one, which is the cheapest? Both are having the same value. So we have to expand both. So B is connected to A and D and E. So now what is the distance now from S to A with B? S to B is 6, from B to A 4. So that is 10. D is also having 10. E is having 12. Next, if I expand the E, what are the nodes connected to E? B, D and F. So if I go for from S to E and E to B, 12 and D 12 and F 6 plus 4 10. Okay, this is the partial solution we found till now. Now which is the best least one we're having? 10 10. So we are having A with 10, D with 10 and F with 10. So we need to expand all this. So if I expand A, what are the nodes connected to A? C. So again I am not writing the B, already we are coming from B. So C. What is the path now? 6 plus 4, 10 plus 2, 12. Okay, now D, if you expand the D, what are the nodes connected to D? D is connected to C, F, E. C, E and F. So for C, what will get? 16 and E also 16, F also 16. Okay, next if I expand F, what are the nodes connected to F? D and G. I'm not writing the E. So D is 16, G is 16. Okay, now what is the minimum? Now we are having C is 12 and B is 12 and D is 12. Now expand all these things. So if I expand C, that is only the option Z. So next it is 14, C to Z is 4, 2. So 12 plus 2, 14. Okay. Next, if I expand this B, we are connecting to A and D. So this is 16 and this is 16. If I expand D, D is having the connection to C, E and F with values 18, 18 and 18. From D to C again. So up to D we are having 12. Again we are moving from D to C, D to E and D to F. So now you see which is having the minimum? Z. So this is the having 14. Cost is 14. The path is S, B, A and C. Okay. Okay. So path is 14 and S, B, A, C, G is the path. Okay. Now for the tiny map, A star didn't find the shortest path because A star we got it as 16. Now branch and bound got 14. So branch and bound found the shortest path and A star didn't find the shortest path. Okay. Now while coming to the group 3, so this is the graph. The Manhattan is 1. The each box is having 1 and 1. So that's why whenever we are calculating, we will get it as 6, 7 like that. But here, this is each is 10. So count that one and multiply with the 10. Okay. So the same similar fashion you calculate. You will get this as the best first search. This is the path and this is the cost. And in the A star, they are asking us to write the first 5 nodes. Okay, from the second node to the sixth node. They didn't ask anything about the path. So IMKOL is the nodes visited by A star. Follow the same procedure whatever we discussed in last questions. Okay, now they are asking us to write the F values. F values means G of n plus H of n values, whatever we wrote. For I we got it as 180. Next, so you see in the A star algorithm, we are moving the least, which is the node having the least f of n value. So IMKOL, this is the way how we are moving from the open list to the closed list. I is having 180, M is having 190, 200, 210 and 215 like that. It is go on until we reach the goal node. Okay, what is the path found? This is the path found by the A star and this is 230 is the